pseudoephedrine? Pseudoephedrine, often known by its brand names Afrin, Dimetap, Drixerol, or Sudafed, is an adrenergic drug and functions similarly to neurotransmitter molecules such as epinephrine and norepinephrine. In fact, it is used to mimic these molecules to stimulate similar physiological response in humans. Although pseudoephedrine seems like it should be a simple over-the-counter drug to treat congestion that typically comes with the common cold, production and distribution of the drug is actually highly regulated. Why? The hydroxyl group on the molecule can easily be reduced into methamphetamine. Nagasaki and Nagai isolated both ephedrine and pseudoephedrine from the ephedra shrub in 1885 and passed it on to his student Kei Muira. Being unaware of Nagai's previous research, in 1923, Ho-Kui Chen and Carl F. Schmidt rediscovered pseudoephedrine. Pseudoephedrine is the diastereomere of another adrenergic drug, ephedrine. They are stereoisomers, but while they both look almost identical, they have differing biological effects. Ephedrine tends to cause blood pressure to rise, so it is often used to help treat low blood pressure, especially during anesthesia. It can act as a nasal decongestant, but more often, pseudoephedrine is used, as it provides the sinus relief without the highly stimulating effects of ephedrine. Adrenergic drugs like pseudoephedrine function using adrenoreceptors, which are a class of G-protein coupled receptors. G-protein coupled receptors consist of a bundle of 7 helices that span the cell membrane and a heterotrimetric, or 3-component, G-protein. G-proteins are signaling molecules that activate cellular responses by replacing GDP for GTP. Pseudoephedrine specifically binds to the alpha and beta-2 adrenergic receptors, which elicit a biological response in the sympathetic nervous system, or known as the fight or flight response. Pseudoephedrine molecules binding to an alpha adrenergic receptor cause blood vessels in the mesomucous membranes to vasoconstrict, and molecules binding to the beta-2 adrenergic receptors cause smooth bronchial muscles to relax. So, pseudoephedrine can be used as a nasal decongestant. Binding to alpha and beta-2 adrenergic receptors causes decreased mucus production and dilation of airways to make breathing much easier. Thus, the biological applications of pseudoephedrine. How is it chemically synthesized? Here's the full synthesis scheme. It's kind of long, so let's take a closer look at the mechanism of the first step. The first step involves attack of the carbonyl carbon by ethanol to form an acid-catalyzed hemiacetal intermediate. Wow, that was a lot of science. What should you take away from this video? Just remember that pseudoephedrine is a drug that can relax muscles in the sinus to relieve nasal congestion,